Welcome back to our engineering series. This is part 2 of our video series, and there are 3 parts. In our previous video, we explored what engineering is, what it looked like, and we provided the 5 primary fields of engineering. This video, we're going to be diving into something really interesting, the engineering design process. The engineering design process is kind of like a roadmap that engineers follow to solve problems and create solutions. It's a real systematic approach. In other words, they follow a particular order that helps turn ideas into reality. Whether engineers are designing a simple pencil holder or a complex rocket, they follow similar steps to make sure their solutions work well. What's great about the engineering design process is that it's not just for engineers. It's a powerful problem-solving tool that anyone can use for any subject area. In fact, you might already be using parts of this process in your regular lives without even knowing about it. So let's explore how engineers think and work through problems and create some amazing solutions that improve our world. I hope you're ready to discover the engineering design process. Let's go ahead and get started with a different video.
We know people's names, we call the people we serve our guests, and we work really hard to ensure that they leave feeling better than when they came.
You're not looking at a high-end hostel or a spa for hipsters. Nope, it's a mobile shower on a bus, and it's delivering hygiene to San Francisco's homeless.
We basically take retired public transportation buses and convert them into toilets and showers on wheels.
That's Donice. She's the founder and CEO of LavaMay, the nonprofit responsible for this project. It all started with her idea.
I literally passed a young woman who was on the street crying that she would never be clean, and it made me wonder what her chances were for getting physically clean. So I went home that evening and did research, and what I found was appalling. There were about 16 shower stalls for 3,500 men, women, and children who literally live on the street. And I thought, that's crazy. This is not a third world country, and yet here in San Francisco, one of the most affluent cities in the world, we have issues with access to water and sanitation. I just started thinking, if you can put gourmet food on wheels and take it anywhere, then why couldn't you do that with showers and toilets?
Turns out you can. She got some old city buses donated and solicited a team to help.
We went through various design phases to understand how many people, how many showers could fit inside the bus.
That's Brett. He's the architect who designed the buses.
A very critical, fundamental part is reaching out to the homeless population.
So we talked to a lot of people and we did a focus group, and we heard 2 things consistently. One was that if you're homeless, you spend your entire life in the public eye. You never have a moment of privacy. And the other was that if you're a woman or you're LGBTQ, the incidence of attack in showers is really high. So we knew pretty quickly that we wanted to create private, safe spaces for people to use.
So given the size constraints and user needs, they had to figure out how to fit everything.
We could really only fit 2 shower units, so there's complete privacy for 2 people taking showers simultaneously.
In addition to addressing the technical constraints and engineering challenges, there's also the creative part of the design process.
Thinking about light, space, and material and experience.
So how did they turn their design into a reality? Enter Airco Mechanical, the company responsible for building the buses. They had a lot of questions.
We looked at it going, okay, how do we get 2 toilets, 2 sinks, 2 showers? How are we going to build this?
That's Chris. He spent a lot of time working on these buses.
There's a lot of problem solving that goes on, and that's where the challenge is, and that's where the reward is solving problems.
That's Wyatt. He's in charge of Airco. The Airco team had a lot to figure out. How do you heat the water? How do you store the water? How do you waterproof the whole interior? The list goes on and on.
We had to go in there and just rip out all the seats and just get it to the bare bones of just a cold shell, and then take the architect's concept and then go in and start building the walls, putting in the plumbing, running the electrical.
But in the end, they figured things out. Here's how they got these buses to work. Carrying water on board would destabilize the bus, so they get their water from fire hydrants. They hook up a water meter, so they pay for the water they use. The used shower water is collected in a tank, and they have special permission to drain the water directly into the sewer. The sewage from the toilets, it's stored in a tank under the bus and then taken to a treatment facility. So far, they've built 2 buses. They call their first bus their prototype.
So knowing that bus number 1 worked, you take that pride that you did in that one and you move it on to the next one and go, hey, we're going to make this thing better than before.
We launched our pilot in June of 2014. So to date, we've served just over 2,000 homeless San Franciscans, providing almost 4,000 showers for them.
There are plans to expand the fleet, and with each new build, there are bound to be new improvements.
Wow, what an interesting application for engineering. Did you notice how it showed how engineers in San Francisco not only converted old city buses into mobile shower facilities, but it showed the design process from coming up with an idea, in other words, defining a problem, and figuring out ways to solve the little problems within the overall big problem. It's a great example of the engineering design process in action. Now let's think about what needed to happen to make these shower spaces, right? The engineers needed to consider water supply, drainage, privacy, accessibility, safety, efficiency, mobility, maintenance. All of those were within the constraints of limited space and budget, and of course, environmental concerns. Now, before we dive into the formal steps of the process, I'd like for you to think about what steps you might have, or you might take if you were designing something new. Whether it's like the buses that you saw converted over, or something completely different like in the world of technology. How would you approach the problem? What would you do first? How would you test your ideas? Well, let's go ahead and take a look at another video so that we can dive further into the design process.
The engineering design process is a lot like making tacos. Here's how. Let's say you've had a long day. Maybe you've gone to class. Maybe you just got off work. Maybe you just finished an intense workout session. It's now 7 o'clock and you're hungry, but you've got friends coming over in half an hour. So, what do? You go through the engineering design process. First, you define a problem or need. In this case, the problem is you're hungry and you've got people coming over in half an hour, and they might be hungry too. Next, you do some research to figure out the design requirements and your limitations. So in this case, you'd assess things like ingredients you have at hand, money you've got to spend, how much time you have before people start showing up, how many people you have to feed, and if any of those people have dietary restrictions. Once you've got a pretty solid list of criteria and constraints, you can start brainstorming ideas for solutions. Maybe you look online at nearby food options. Then, maybe you go to the fridge and you start figuring out what you could make. You weigh your options and you determine making something at home will be cheaper and faster than ordering something online. And you decide everyone likes PB&J, but you don't have gluten-free bread.
Oh.
But you do have corn tortillas.
I guess I'll try PB&J on corn tortillas.
And you make a prototype. You test out and take a bite. It's gross. But you want to make sure it's not just you, so you get others to test out, like your roommates or family. Everyone agrees. It's gross. You ask questions and determine what's gross about it. In this case, your testers like the tortillas, but not so much the PB&J. So you go back to the kitchen and reassess. This is what engineers call iterating, making changes based on test and user feedback. You realize,
I've got ingredients for tacos? Dope!
So you start making some veggie tacos. You try one and think,
This is kinda dry.
you have other people try it to get their feedback. Most people agree.
It's kind of dry.
So you go back to your kitchen and start iterating again. You find that you've got the ingredients to make guacamole. You make the guac and you add it to the tacos. You test it out and you're like,
This is tasting pretty good.
but some of the other testers think,
It could use some spice.
so you evaluate their feedback, you look in your kitchen, and you realize you don't have anything spicy. That's when you call your friend Sam who's coming over. And you're like,
Hey Sam, can you bring over some hot sauce? I'm making tacos.
and Sam's like,
Sure.
also,
I love tacos.
it's now 7:30 and your friends start showing up. You tell your friends,
I made tacos if you're hungry. You can add hot sauce if you want.
and then you and your friends eat the tacos. They're like,
These are pretty good. I'm gonna Instagram that.
You should share the recipe online.
so you do. You've solved your hunger problem and engineered a taco party.
So the engineering design process typically includes 7 main steps, with each one being as important as the other steps. So let's walk through them real quick, and of course you can follow along as I go along here. All right, we have first, engineers ask questions to understand the problem. They investigate the situation and identify specific needs and clearly define what they're trying to solve. Next, they imagine possible solutions. This involves brainstorming, which means coming up with multiple ideas and different ideas, and then they judge them to select the most promising options to explore. The third step is to plan. In other words, they draw sketches or create digital models that develop detailed specifications for their solution, and then they create prototypes to maybe visualize or to hold the original versions in their hand or even test those out directly. And then, of course, once they do that, they come to the testing phase where they evaluate how their prototypes are working, and then they try to iterate, in other words, change the ideas based off of what they learn. And then if anything is unexpected revealed during the during the testing, they can overcome that as well. And then, of course, the next step is to improve the design. And engineers redesign and iterate based off of models, and they continue to go back and forth between designing, changing, asking questions why this happened, maybe make some changes, and so on. And then, of course, they finally communicate their results, and they share their findings. And maybe they go back over and do it all over again for a continual improvement. In fact, there was a story that when it came time to devise or design the very first iPod that was created by Apple under Steve Jobs rejected a lot of ideas because they didn't contain exactly what he was looking for. So something to consider there as well. And he kept on going back to the engineers, make it better, let's change this, let's go that. And they came to him with final approval. So now that we understand the basic steps of the engineering and design process, let's consider some important questions about how it works in practice, right? Thinking about the mobile shower example that we saw earlier, which parts of the design process do you think were most important? Some would argue that in the ask phase, that's really important because you have to ask questions to understand the problem, or your solution won't really address the needs. Others might say you got to test it first to see what changes need to be made and improved on, and that's where critical learning happens. Here's another question to consider. Can any part of the process be skipped? While it might be tempting to just jump straight into the creating process, each step serves with an important purpose. Skipping often leads to design problems later on. For example, if you don't thoroughly test your design, you might miss critical flaws that cause your solution to fall apart when it matters the most. the engineering process is not necessarily straightforward. Okay, they call it linear, following step by step by step by step. It often moves back and forth, as I just described a few moments ago, and there's new steps that may need to be formed with new information as it appears. It is a flexible process. It is iterative, meaning, in other words, you can go back and do steps if needed, if it helps the final product of the or the final solution for the product itself. So, with that in mind, before we get to video 3 in a moment, or for the next day, into the engineering design process is very powerful because it combines creativity with systematic thinking. It encourages us to deeply understand problems before rushing to solutions, to generate many ideas before committing to just one idea, and to test and to improve our designs based on real feedback. It's a real scientific process. What's really exciting about the engineering process is it can be applied to almost any problem, not just engineering challenges. Whether you're designing a school project, planning an event, or figuring out better ways to organize doing your assignments or classwork or coursework, the engineering process can help you create better solutions. So for our next class, I'd like for you to observe, if I get the words out, how the engineering process might be used in everyday solutions. Look for examples of products or systems that have clearly been improved through multiple iterations or designs. In our third video, we'll start to explore the engineering design process to a real challenge and that may need to be solved. In other words, we'll define a problem and then see how we might be able to solve it. And we'll walk through each step to see how the engineers turn problems into opportunities for innovations. Again, thank you for joining me on video 2, and make sure you watch video 3 to finish up the series.